The broadcast is now starting. All attendees are in listen-only mode.
Welcome, everyone. My name is Jeff Apsley, and again, welcome to our webinar today. We're going to be going through some content dealing with Citrix App Layering, as the marketing has talked about. This is a webinar that's introducing the Citrix App Layering, and it is hosted by Citrix Education. Please submit questions that you have to the chat log. And if we have time at the end, or we'll take a break in the middle also to address the questions, but we'll attempt to answer them all. If we can't cover all of the questions in the time allotted, then we'll produce a follow-up communication addressing all remaining questions. So let's go ahead and get started with the webinar. Citrix App Layering. What is it? What does it do? We're going to talk about that. It basically simplifies management. Now, it simplifies management, as the screen says, of your operating system. It simplifies management of the applications as individual entities. And it allows you to compose and manage multiple images and image layers as required. Now, we're going to talk about how this happens. We're going to talk about how app layering could and does simplify management, and how possibly it could solve your operating system and application management challenges. We'll introduce Citrix App Layering, and we'll talk about the app layering architecture. So how does it work? Well, you've got the layer preparation, the layer management, and the ELM repository. Now, the ELM repository is where we store the components that we put together. So the ELM, or Enterprise Layer Manager server, that's in the center panel. That layer management, the ELM, that server creates layers by using the connector for the targeted hypervisor to build a temporary virtual machine. This virtual machine is then used to package the layer that you want to create. This temporary virtual machine is called the packaging machine. The packaging machine is used to deliver or create that desired layer. For example, if you wanted to create a new application layer for Microsoft Office, you would install the Microsoft Office application on the temporary virtual machine, and then it would create the layer. But really, how does it work? Well, step one, you have the console, the Citrix Layering Management Console. It is what we use to manage the Enterprise Layer Manager. So from within the Layer Management Console, you would start the process by choosing to create either a application layer, or maybe a platform layer, or an operating system layer. The ELM server then uses a connector to build the packaging machine. In other words, the ELM will talk to your hypervisor and create the packaging machine for you. Step three, then you install the targeted apps, or possibly the operating system, into that packaging machine. Step four, then you finalize the targeted install by shutting down the packaging machine using the app layering finalization software. Step five, after the shutdown, the ELM server captures and stores that layer that was requested from the layering management console. Step six, the virtual machine packaging is then deleted, as it is only a temporary virtual machine created just to create or update a targeted layer. Layering enables any application to be captured as a virtual disk called a layer. Layers are attached to virtual machines and combined with other layers using the file system and registry virtualization so that they appear to be locally installed. With layering, you can create an operating system layer, a platform layer, and app layers, one or many, and then use it to create any number of combinations or images. Each app layer can include one or more applications. An operating system layer contains the operating system, of course. When the operating system and the apps are layered, you only need to install each one once. These layers can be updated by adding a new version to the layer. This updated layer can then be used to access the other layers and deployed images. This allows you to maintain a single operating system layer used across these multiple images. If you need to support more than one operating system, you can create more than one operating system layer. For example, you can create a different operating system layer or OS layer if you need both Windows Server 2012 R2 and Windows Server 2016. It's important to know that each app layer is only compatible with the OS layer used to create it. A platform layer contains your hypervisor, provisioning service, and connection broker software, and it isolates the apps and the OS layers from the infrastructure where they'll be published. So that's how it works as a high level. It is a great idea. App layering is a process and a technology. App layering is a process used to deliver a complete virtual desktop to an end user. We can create and manage the following types of layers. Again, the layers that we can create are the operating system layer, the platform layer, application layer, and elastic layers. App layering is an app imaging management solution. It is a process and a technology, as I said a moment ago. App layering allows you to individualize virtual machine components into specific layers. It takes application complexity and makes it an application layer. It takes hypervisor complexity and makes that a platform layer. It takes operating system complexity and makes it an operating system layer. The layering process creates and manages the following types of layers, as we said a moment ago, and you can see on the screen, starting at the bottom, the operating system layer, the platform layer, the application layer, and the elastic layers. Now, within that elastic layer, there's another layer called user personalization layer. We'll talk about that a little bit more in a moment. So how does it benefit us? Well, as an administrator, it simplifies application and image management. Now, the image is what is built by adding all of the layers together. When they're merged together, they become an image, and we push that image out to a provisioning service, either machine creation services or provisioning services. It gives us faster application packaging. When I need to create a custom application or a custom virtual server, or even a catalog of multiple virtual machines, I can then rearrange the layers or add or remove layers as needed without rebuilding the layers themselves. It helps in high availability. It helps in real-time application delivery and management. Deploy, it helps us to deploy the application package on any infrastructure, any hypervisor or cloud. It also eliminates managing multiple gold images or multiple core images. In many organizations, when we build an operating system, we have to get it approved from security. We have to make sure that the vulnerabilities have been dealt with. We have to make sure that the right drivers have been loaded. We have to make sure that that core build is always adhered to. With app layering, it's very simple. You build one of those machines or one of those operating system layers, build in all of your security features into that layer, and then use that layer for multiple images that you can deploy for different groups. And the beauty of the management layer is that if I need to patch that operating system, I can patch it once and all of my different packages are automatically updated. And so here we've got the reduction of overall app and desktop management costs by some estimates up to 80%. And it's very, very valid. Each of the layers that you build are read-only, so they're protected. And every time you launch, you get a brand new copy, a brand new instance of those layered applications, and the operating system layer, the platform layer, and the application layer. But there could be a question. And so an engineer might bring up, what if I have users in a group that need more or less than other users in a group? So I've got a group. Let's say I've got a group like accounting, and the vast majority of the people in that group, and we're talking about an Active Directory group, in that group, the vast majority of the individuals need a basic set of applications. But within that group, we have managers, the accounting managers, and they need additional additional applications, additional functionality. Can we address that? So an app layer that an administrator can deliver dynamically based on the entitlements when the users log on to a session, or a standalone desktop? Well, this answer allows the administrator to give each user his or her own unique set of applications at logon. And it can drastically reduce the number of base layered images that administrators need to maintain. The elastic layer is an app layer. A copy of the layer is stored in the appliance network file share and delivered to individual Active Directory users or groups on demand, in addition to the layers that they receive via the base image. To use this feature, you'll add elastic assignments specifying which users and groups should receive each of the app layers. Elastic layers do not become a part of the image like app layers do. The app layers and the platform layer and the OS layer are merged at the time they become an image, and the image is pushed out to your provisioning service. But these layers, they're applied at the time of login. Elastic layers can significantly reduce the number of images needed. The user layer is a virtual disk. It's managed and delivered like elastic layers, but not limited to application delivery. The user layer provides persistence for user profile settings and other data when they're connected to non-persistent VDI machines. You can enable the following types of user layers. You have a full user layer, and it basically captures all of the user's data, settings, and locally installed applications are also stored on their user layer. In other words, if we give a full user layer to an individual, they are able to install their own applications, and it's kept in that user layer. Then you have another type that's the Office 365 for desktop systems. There's also a session Office 365 for session hosts or Citrix virtual apps and servers. So the session only uses the Outlook data, has a place to store the Outlook data, and settings are stored on the individual user layer. Now, if you're publishing a desktop, then only the user's Outlook data and the settings are stored on the user layer, yet they're merged, and it looks as if it's all installed on the same hard drive. They're merged during the login process. So that's a real high-level overview of what app layering is. Citrix App Layering, we talked about how does it work. We talked about that it's a great idea. It saves us time and simplifies management. It also provides a lot of reliability because we're using fewer parts and reusing for consistency the parts that have been approved. So the management benefits we talked about, and we talked about, hey, can you personalize it? Or does everybody need to fit into one of these core groups that we're building this application for. So we've looked at all of this at a high level, but there comes a question, and the question is, how does app layering fit into the Citrix community of business solutions? Well, the answer is obvious: time management. This year, Synergy was in Orlando, Florida, and the keynote speech on the very first day, the keynote speech brought about this idea of Citrix. If you use Citrix products, we're going to save you time. And we talked about the Workspace app and how when we add intelligence to the Workspace app, we're hoping to smooth out and streamline the workflow so much that we could save as much as 8 hours in a work week. 8 hours for the end user to be more productive, to be less tied up in context switches. That means stopping one task in order to start another task. So the community, Citrix community of business solutions, we have kind of split in the middle. We've got end user solutions and administrative solutions, and they're all geared to save time, to increase reliability, to give a better experience for both. Now, in the end user area, we've got Workspace app, we've got our virtual applications, our virtual desktops, we've got intelligence and analytics that we're combining into the work environment, and we've got micro apps, and there'll be a lot more talk about that in the near future. But that all gives the end user the ability to save time and to have more time available to concentrate on their tasks. On the administrative side, we have management tools. The management tools are the Citrix Cloud, WEM, NMOS, Studio, Commander, machine creation services, provisioning services, and app layering is part of that management layer that also gives us the ability to save time and create better quality products or better quality results that the end users enjoy and administrators find easier and easier to manage. App layering is, again, an image management solution. Up until now, we've provided a high-level explanation of app layering. App layering is an app image management solution. It is also a process and a technology. Layering is a process that is used to deliver a vDisk to virtual machines that are the workhorses that carry the load for CVAD, or Citrix Virtual Apps and Desktops. Not only does the hosted workspace provide benefits to the end users, but the hosted workspace is the core of any type of deployment. And that hosted workspace can be located just about anywhere. It can be located on-prem. It can be located in your data center, in a failover data center. It can be located in a private cloud. It can be located in a public cloud. And the very nature of a hybrid multi-cloud environment, it also can be delivered, that hosted workspace can be delivered across multiple clouds and multiple locations simultaneously. But let's take a closer look at app layering in the next couple of slides. Do we have any questions before we move a little bit deeper? Leslie?
Hey, Jeff. Yeah, there is a question.
Okay.
It says app layering will replace personal vDisks, but in PVD, we have not only apps, we have personal folders. How can app layering manage personal folders, or personal folders must be managed with profile management?
Very good. In the management of the user's profile, We can use Wim to do that, or Active Directory group policies. So we manage the profile the same way that we do when we're not using app layering, but that profile can be on a network share, or we can create a user layer to house that profile and then save that profile off and reattach it when they log in. Okay? That way it would look as if it was a local profile rather than a roaming profile. Okay? So there's multiple ways of doing this. The personal vDisk, great idea, but very difficult to implement. And if you implement it at wholesale, in other words, across the board, it consumes a lot of resources and can be problematic. And so that's why it's being deprecated for this technology. Okay, so the elastic layer allows you to pick and choose what application you want to deliver to what individual within a group, whereas the user layer is where we would keep those profiles or allow the user to install their own apps and make it persistent even when all of the other layers, the operating system layer, the platform layer, and the application layer, are non-persistent. They're read-only. Okay? I hope that answers the question.
Yep, so there's a follow-up. For a few users, less than 30, would you recommend PVD or app layering?
I would definitely recommend app layering. Definitely. And the reason is it's not a scalability issue. If you have 5 users, if you have thousands of users, app layering makes a good case on management level. For example, if you were to take a server operating system, Microsoft's operating system, server operating system, and you build a virtual machine with just the server on it, it's very stable, incredibly stable. In fact, the only thing that makes it unstable is us administrators adding applications to it. We might add an app that will conflict with another app or conflict with the security settings that we put on the operating system layer. And so if we separate the operating system from the app layers, that gives me the ability to patch and update my operating system layer without touching my application layers. Same thing. If I build an application layer for an accounting package and a separate application layer for, say, my productivity apps like Microsoft Office, then I can at any time use those layers in multiple images. So I've got my Microsoft Office layer, and I use it in a group package for an image for accounting, and an image for developers, and an image for managers, an image for shipping and marketing and whatever. I only need to patch that layer once, and everybody gets the patch. And so it does definitely help, even in small layers, small deployments. I would definitely recommend app layering as opposed to PVD at any time. Okay? So it can create these virtual machines and create the catalogs for you and populate the catalogs with machines, all built from a common image that you are managing using the ELM. Okay? Any other questions?
Yep, we've got a couple, but here's a good one. Can you control application isolation or application first run options on app layers?
Good question. By definition, okay, what we're doing is we're isolating the management, not necessarily the application. Remember, they are merged together and they behave as a single disk, a single vDisk. Okay? So we don't isolate in that we have multiple versions of an application within a specific layer. Now, what we can do is we can isolate them by putting the different versions of that same application in different layers, and then selecting which layer is needed by which user at what time. So they could log in and get version 1 of the accounting app. They could log out and log back in and get version 2 of that app based on the user profile, based on our management of the ELM, or the enterprise layer manager. Okay? So again, to address the question, isolation, application isolation, what we do is we merge the layers together to create one item. Now, let me back up a moment and say that by its nature, there is automatically some mode of isolation. In other words, in my operating system layer, I put in a setting in the registry, okay? And that setting is predatory to my applications. I then use that operating system layer to create, with that virtual machine that the ELM stands up, I use that operating system layer to create a application layer. And in that application layer, when I create that, I install that application and it changes that registry setting. Okay? That change is recorded in the app layer, so that when we merge the two together, we get the result of having the operating system layer modified when that layer is merged with it. Okay? But when I don't merge that layer, then at that moment, the original OS is still in its native state. Okay? Maybe I merge a different layer and there's not that change. Only when that layer is merged does that change take place. So there is a bit of isolation that goes on, but it's in a merging process, not a fencing process. Okay?
Yeah. And then just one more question.
Okay.
With PVD users, they can install their own apps. Is this the same with app layering, or only the admin can add applications?
Okay. The answer is yes to both. If you're going to add an application to a application layer, only an administrator can do that. Okay? But if you add an application to the user layer, then the user can add that and it will be persistent for that user. Okay? So yes, users can add their apps to the user layer and it's persistent for them, but a user cannot add an app that will be shared with all users. Only an administrator can create or add an application layer that will be distributed and used by many people, okay, within the group. I hope that answers the question. Okay, we're going to take a closer look at each of these layers in just a moment. Are there any other questions? Leslie, I don't think so. So let's continue on. Let's take a closer look at the app layering technology. In order to do that, we have to talk about the nomenclature or the vocabulary. There's a lot of terms involved in app layering concepts. Some of the terms that you see on the screen are the ones that you would need to be comfortable with in the environment when you manage it. What is a layered image? Well, it's a bootable image, and it's a composite of an OS layer, a platform layer, and any number of application layer images. They're published using the image templates, and these are the templates are where you save your layered selections for a particular use. Image template. An image template saves the operating system layer, application layer, and platform layer assignments. that you've chosen for any layered image. The OS disk, the virtual disk containing the operating system that is imported to create the OS layer. To prepare the OS disk, you'll need to install and configure an operating system on a virtual machine that was created by the ELM and then removed when the ELM shuts down the process. The OS machine, the operating system machine, is a virtual machine that you create from which you can generate an operating system disk and an operating system layer. The packaging disk, a bootable virtual disk used to create a packaging machine needed for creating or updating a layer. Packaging machine, a virtual machine that acts as a staging area for the creation of app layers, app layer versions, and operating system layer versions. A layer, as you see here, a layer is a virtual disk that can be merged with others. A layer captures a Windows operating system, Windows applications, or the configuration settings, and the tools required for the image to run on a particular platform. Layers are created from a simple install of the application or the operating system. You can select any combination of layers for each layered image. You can reuse the same layers in any combination to provision a variety of servers and desktops. I think we know what the OS layer is. It's a virtual layer containing the operating system. The app layer, it's also a virtual disk containing one or more applications that you can use in any number of layered images. In other words, in that app layer, I can put one application or I can put many applications. I can create as many app layers as I need and then mix and match them as needed for the needs of the end user. Top of the second column, we have a platform layer. The platform layer is a layer that includes the configuration settings, tools, and other software required for images to run on a particular platform. The elastic layer. The elastic layer can be delivered based on user entitlements when users log on to sessions or standalone desktops. In other words, the first three layers, the OS layer, app layer, and platform layer, are merged ahead of time, ahead of need, and then at the time of logon, we add the elastic layer. A prerequisite layer is a layer that when an application requires helper apps, when installing other applications for a new application layer or layer version. For example, you would select your Microsoft Office app layer as a prerequisite layer when installing Microsoft Office plugins in a separate layer. Or you would select the Java app layer as a prerequisite when creating a layer for applications that require Java. Connector. A connector is the interface to the environment where the layers are created and the images are published. Connector configuration is a stored set of values that the connector uses to connect to a specific environment. Directory junction, settings that define a connection to a distinguished name in a directory service such as Microsoft Active Directory. Directory service is a repository of information about users, devices, services, and it's usually located on the network server. Microsoft Active Directory and LDAP are examples of directory services. We use it for authentication. We use it for management, profile management. We use it for organization of our resources and our users. Enterprise Layer Manager, the ELM. This is the heart and soul of the app layering components. The ELM, or Enterprise Layer Manager, is a virtual appliance that coordinates communication and hosts the management console. It's the administrative interface. The ELM also manages the copies of all of the layers that are created. And then the management console The last term that we're going to define here is the web-based management console, and it runs on the ELM virtual machine. Now that we have the nomenclature out of the way, let's dig a little bit deeper into the different layers. The operating system layer. As you can see on the screen, the operating system layer contains, obviously, the operating system, built to a golden image, built to the specifications that are required within your environment. It contains configurations, settings, printers, printer settings, and so on. And the printers that it contains are the drivers. Now, the provisioning of the printers to the individual users is done through profile management. But the drivers have to be in the base build in order to be provisioned to the user. So in our operating system layer, we put our drivers, our print drivers. Applications such as antivirus agents are also put in the operating system layer. Now, the operating system layer is read-only, and the images can only be updated or patched by an administrator. As you see on the screen, if you have a Windows 10, a Windows Server 2012, 2016, any type of variance in the operating system, you're going to need an operating system layer for each of those. So typically there is one OS layer for all desktops, making patching and updates easy. However, you can have several operating system layers for Windows variants. Like I said a moment ago, Windows 10, Server 2K8, Windows Server 2016, and so on. Again, the operating system layer is read-only. Once a desktop has an operating system layer assigned to it, you cannot change that. You cannot switch a desktop to a different operating system layer. You need to create a new image to populate a new catalog. Desktops can be updated by creating new versions of the current OS layer and deploying it to the desktops. The desktops need to be restarted before changes can take effect. Layering technology can layer any application. There's no need for applications to be installed in the operating system layer. Ultimately, we create a single gold image per supported operating system. And so you're creating this, and you're creating a base layer for that for your environment, and you're putting it in the repository to be used over and over again. Basically, you're turning the operating system layer into a resource, and that resource is managed by the ELM. It should be noted at this point that even applications with drivers, service kernel devices, and so on, they're all supported as application layers. Therefore, they should not need to be put into the OS layer. Okay? Now let's talk about the platform layer. The platform layer contains configuration settings, system tools, and other software that's required in order for an image or a virtual machine to run on a particular platform. The platform layers can be integrated with many different hypervisors or environments, but you need one platform layer per hypervisor host. For example, a platform layer for Citrix Hypervisor would include the Zen tools. For vSphere, it would include the VM tools. The platform layer can be used to move other layers and layer types between different hypervisors without rebuilding the OS layer and the application layers. This enables an administrator to update applications and operating system one time, but then have them distributed out to multiple sites, multiple hosting platforms immediately after updating just one operating system or one set of application layers. It doesn't matter if both of these sites are internal VMware vCenters or if one is on-prem, an on-prem vCenter, and the other is in Azure Cloud. In our platform layer, we make adjustments for where that system is going to be running. All deployments then would use the same base layers no matter where they're running. The platform layer can integrate with many different hypervisors and environments, and in each of these deliver the appropriate hypervisors tools and management tools like the Citrix VDA, Citrix PVS target device software, and so on, all without changing the OS or app layers. And so that's what the platform layer is. It adjusts the OS layer and the application layer to run on your choice of hosting platforms, both on-prem, local, or in the cloud. Next is the application layer. The application layer, as the screen says, contains applications, obviously. It contains software programs which can be deployed to any machine using a compatible operating system layer. It allows me to patch or add plugins for just those applications. So if I do not have that application in my mix, then I don't get those plugins. I don't get the additional software. I don't get the additional overhead. Again, the application layer is read-only and only can be updated by an administrator by adding application layer versions. Now, a single application layer can contain multiple applications, and at a later date, you can add more applications to any application layer. Or it can contain a single application. That's up to you. We can also merge multiple application layers into any image that we provide to a provisioning service. So application layers can also include patches and plugins for programs. They can contain multiple applications. Any data that is written when the application is installed, such as a default directory, file locations, registry keys, all of those are added to that layer and maintained for that application. If there are parts of the operating system layer which need to be modified by the application, they are contained in the app layer and then merged at boot up. Like operating system layers, app layers are read-only and can be only updated by the IT staff. An app layer can include several layers and several layer versions, each of which contains a different version of the application. Different layer versions of the same application can then be deployed as needed. So that's the application layer. Let's move into the elastic layer and the user layer. And you see that on the slide. In that elastic layer, I may have included all of those applications, publisher, and, the whole Office suite, Visio, whatever. And during login time, out of that elastic layer, user 1 only gets 2 applications, but user 2, using the exact same elastic layer, the merging of those components within that layer are dictated by the user's group membership in Active Directory. So user 2 would only get 2 applications, but a different set of 2, as you see on the screen. So in other words, the first 3 layers, the operating system layer, the platform layer, and the application layers, one or many, are all merged ahead of time before being handed that vDisk or that template to the provisioning group. Once that machine is provisioned and is fired up, they're already merged. They're running on a single disk as if that mix that we created was installed, all on the same image. Then, as the user starts to log in, then we add the elastic layers as is appropriate to what has been given to them, what entitlements they have had from the Active Directory. On the other side, the elastic layer and the user layer The user layer is also added right at the time of login, and the merging of those two items, the elastic layer and the user layer, are accomplished during the login process. So to use this feature again, you need to add elastic assignments to specific users and user groups in Active Directory. Now, user layers are also an application layering feature. And the user layer is a virtual disk managed and delivered like elastic layers, but again, we don't limit it to just application delivery or adding or removing applications. The user layer provides persistence for profile settings and other data, even when connected to non-persistent virtual machines, VDI machines. And again, you have three different types of user layers. You've got the full user layer, which captures all the user's data, settings, and locally installed apps. And then you've got Office 365 for desktop and then Office 365 for session hosts. Let's take a look at the architectural diagram here. You got the ELM, or the Enterprise Layer Manager, in the upper left-hand corner of the diagram. The ELM manages its storage or its repository. In the repository, we have our different layers. We have operating system layers, platform layers, you get the idea. We've got all the different layers that the ELM, or the Enterprise Layer Manager, created. So we create those layers, then we store them as inventory. Then we take those layers and we can create a layered image. And we can mix and match them in any fashion that we want, reusing the same layers in multiple layered images. Then the layered image is handed to the delivery controller, which then sends it to the hypervisor. And it's used to create the catalog. It can be used to create desktop virtual machines and Citrix virtual apps servers. The domain controller is used and integrated in order to configure the Enterprise Layer Manager and to set up associations with different groups to different objects within the elastic layer. The database is important. That's where configuration settings are, and the licensing server. And so all of this ties in with the delivery controller. And what it does is it attaches to a non-persistent deployment. Now remember, a non-persistent deployment is a read-only deployment. Of course, while they're up and running, they have a write area where they can write temporary files that are used during the running of that application and that operating system. And so what we do is we attach our layered images to the non-persistent, giving it persistence. Okay, so that's the architectural overview. Moving on, the Enterprise Layer Manager, again, it is the core. It is a virtual machine, a Linux-based virtual appliance. You download it and you run it on your hypervisor. We have versions of the ELM that run on Citrix Hypervisor. They run on Microsoft Azure, Microsoft Hyper-V, Nutanix, AHV, VMware, vSphere. We've got a version of the ELM that's available. We also have a version of the ELM that runs in Citrix Cloud. The Enterprise Layer Manager is also known as the App Layering Appliance. The App Layering Appliance hosts the App Layering Management Console. Within the Management Console, you can create and assign layers and images or directly to users by using the Elastic Assignment. If you don't use the Elastic Assignment or Elastic Layers, you are applying images directly to machines. If you want to apply those resources not just to machines but to individual users, then you use the Elastic and the user layer. And it installs and manages a single copy of your Windows operating system and a single copy of each of your apps in their single layers. That's what the ALM server does. It manages all of that. You can select any combination of layers within the ELM to be creating a layered image that are deployed to session hosts. That's the ELM server. How do we configure it? Well, to install and configure and ultimately use the ELM server, you must, one, install the ELM or the Enterprise Layer Manager, VPX, virtual machine on a dedicated or virtual host, hypervisor. Okay? Now, the hypervisor doesn't need to be dedicated, but the machine that the ELM is loaded on has to be dedicated, and it's a Linux machine. We download those machines from a Citrix website. You start the ELM, which is a Linux-based appliance, from within the hypervisor. Then you log on to the console. By the way, the default credentials are for the administrator. The default credentials are administrator, and the password is Unidesk1. That's capital UNIDESK1. Those are the default credentials. And you don't log into the GUI right away. You log into the CLI, the command line interface. You use App Layering appliance configuration to make adjustments to the ELM password, network settings, time zone, and time server, the NTP server. So once you log in and you make those adjustments to the command line, then when you hit save to that, it restarts that machine. And the new configurations are then applied and take over. At that point, then you can use the GUI. When you log into the GUI, you can enter a new password. There are two separate passwords, one for the CLI, even though they're both the super user. The CLI has a separate password from the GUI. And so you can have two different passwords to enhance security in your environment. So once the following options are required for configuring from the command line, you need to tell the system whether or not it has static or dynamic networking addressing. If it's static, then you need to give it an IP address, a net mask, a gateway IP address. DNS1, DNS2, those are optional. Then you have all the available options to quit, save, redo, all of that. And those are all available from the CLI. Once the CLI has been configured, or the ELM has been configured from the command line, then we access the App Layering machine console via web browser. We log in again using administrator, password Unidesk1, but it'll ask you right away to change the password. We accept the Citrix licensing agreement. We change the App Layering web console password. We review the Welcome To screen, and then any additional configurations for the local or the location of the network file share, pardon me, or where I locate my objects. That's all part of what is configured from the GUI. Requirements, storage requirements for the ELM server. It's recommended 350 to 500 gigs of local storage space is recommended highly. Okay. How App Layering creates layers? Well, you log into the management console, you tell the App Layer to build me a layer. It then talks to the hypervisor, it creates a temporary package, we install those apps, then the App Layer, Enterprise Layer Manager shuts down that machine, then it creates the layer and it stores that layer in the repository where, using again our Citrix Layering Management console, we can reassemble those layers in any fashion and create the image. How it creates a virtual machine? Well, we take those images, we merge them together with the platform layer needed to run that virtual disk or virtual machine on a targeted hypervisor. The boot process, the layered image powers on, the user starts to log in. During that login process, the elastic layers are mounted and the user completes the login process and they have a machine just for them. This is what the Citrix App Layering Management Console looks like. You've got an area where you manage the images. You've got layers where you manage the individual layers. You've got users and system. Now we can connect to the management console by connecting to the IP address of the ELM using a browser. Now, there are two methods of management. On-prem, using the Citrix Layering Management Console that you see on the screen, and it can be launched via a browser, or Citrix Cloud. The Citrix Layering Management Console can be launched via the Citrix Cloud. App layering connectors, there are two types of connectors. There's one connector that the ELM uses to create the images. It creates that virtual machine, then we install the layers, and then the second connector, the second type of connector, is used when the ELM server publishes the images for production. This type of connector is host aware and provisioning engine aware, such as provisioning services or machine creation services. So the key takeaways from today's webinar are that the app layering technology provides faster, simpler, and more cost-effective delivery for a real-time application and image management. The ELM server is the heart and soul of the whole environment. It is the primary component of the app layering architecture. It coordinates all communication. It coordinates hosting the administrative portal and managing all created layers, their storage, their acquisition, and their mixing and bundling together to create the layered image. And the last takeaway is that the Citrix Layering Management Console is a tool that will save you time and money. The console can be used to create layers, publish layered images, and configure various system settings. And with that, I think we're done with the webinar. Do we have any questions?
Yes, we do. So if the layers are read-only, how do we add new layers or reduce them as needed?
Okay. The layers themselves are read-only in the deployment. In other words, when they are bundled in an image and handed to the provisioning, it is read-only when they boot up. They're not read-only when I, as a manager, load those images in the ELM. They're open. At that point, I, as an administrator, can add and remove or patch those objects. But then, once we save them off, then they become read-only again. Okay?
Next question, is Microsoft Server 2019 supported with app layering?
Yes, it is. Absolutely. Yes.
Is Nutanix AHV supported as a platform layer?
Yes, it is. Yep. Boy, great questions. Quick answers.
Yeah. How do elastic layers affect login times?
Okay, good question. Again, the act of merging them together is very, very quick. You probably won't even see it. What does extend time is if you have to read in a profile, a very large profile. That is just a normal read-in time, okay? So we still want to do profile management with that elastic layering, but the merging in is very, very quick. It takes that location, that image, and merges it in. With that being said, there are certain requirements that are needed, such as a robust network, a 10E network, if your elastic layers or user layers are on a network share, like a SAN. So there are considerations that in the class when you take the class, we go through all of those considerations that are there. But remember that networking is not used in the merging. It's used in accessing what has been merged. Okay, so the merging technology happens very quickly. It doesn't slow down the login process. Okay.
So how many elastic layers can you add to a user?
Ooh, wow, good question. You know, I'm not sure. I'm going to have to look that one up because I don't want to give you improper information here. I do know that in the past there was only one elastic layer. I'm not sure if that has changed in the most recent. So let me defer that answer. I will get you the real official answer on that. I know that in the times that I've deployed it, in the consulting sessions that I have been a part of, we've only had one elastic layer per user or group. We can have multiple elastic layers, but each one is bound to a different image. Okay, only one elastic layer per image, that layered image that we present to the provisioning components. Okay.
Okay, so moving on. Can you apply an app layer built on server 2008 to a server 2016 OS layer?
No. Remember, each variant of the OS needs their own OS layer. Okay? So in other words, I've got Windows 2K8 OS layer, and I'm going to be deploying 2016 or 2019. I need to create a new OS layer and then mix and match. Now, each OS layer is going to interact differently with the app layers. So I need to create app layers for each OS layer because we use the OS layer to create the app layers. Okay? But I can have everybody running on 2K8 with their app layers, and in my real time as an administrator, I can go in and create the new OS layer and the new application layers, and then push out to the provisioning component a new image, and one day they're on one system, the next day they're on the next system. It's very, very quick, very easy to manage. Okay?
Yep, and we have several other questions, but in the interest of time, let's have one more, and then we can answer the others via email. So, yes. So Jeff will follow up with the folks who have asked some other questions, but we're a little bit over, and I want to make sure that you know that we are going to get to you via email. But here's one more for the group. So, can ELM be made highly available behind a NetScaler using a second ELM?
Yes, and we talk about that in class, but there are some caveats with that. The ELM is a standalone machine, and because it is not needed during the launching or provisioning, all of its work is done ahead of time. Okay? In other words, it's not dynamically creating these images at launch time. It creates them ahead of time and hands that image to your provisioning component. So really, high availability. If the ELM goes away, you still launch your catalogs. Okay. With that being said, though, I understand the need to make it highly available. Now, as in the class, we will talk about high availability, but the way we do that, they don't share a common database. They don't share a common repository. No, what we do is we create the first ELM, completely configure the environment, and then we create a second ELM. We export all of the settings and the repository from the first one and import it to the second one. At that point, now you have high availability. Now, you wouldn't load balance between them, but what you could do is use the ADC, the Citrix ADC, to select which one is the active one at that moment. If it does have a problem, we can cut over to the secondary one that we have already set up for the HA. Okay, we do talk about that in the course, but we do not create two that share a database or a repository, because the ELM is infinitely in charge of its settings and its storage repository, so they don't share them. Okay, so you would build one, export the settings, import them to the second one to create your HA. And with that, I do believe we are out of time. I've gone 5 minutes over, but you know, an instructor, he's always long-winded. Thank you all for attending our webinar today, and we hope that it was beneficial for you. Appreciate your attention and your time with us, and we hope that you look forward to additional training on the product in order to maximize its effectiveness in your environment. Thank you for attending today.
Thanks so much, Jeff. Have a great day, everyone.